Okay, this is question number 22, and it's talking about vectors, and specifically it's vector addition. To kind of illustrate this a little bit, I want to show you, this is just a quick little video about what's called First Lego League. And I want you to notice these kids, they've built these little robots, and there's a mat. And all the mats are the same with different obstacles and challenges that they're supposed to complete. All they do, and watch what they do, of course, this is them putting attachments on it. They've programmed a little brick, and they're not interacting with it at all. There's not a remote control. They have pre-programmed this to do a series of different things, and you can see they take their hands off of it outside of that little quarter circle. And then at the end, the judge tallies all of the different challenges that they were able to complete. And you can see that these little robots, watch, they turn a certain number of degrees and they head on out to do the program. Now these kids do separate programs for each movement. This is one of the programs that shows that it goes forward a certain distance and then it turns a certain number of degrees. So the reason I bring that up is that vectors are very similar, by the way, and then you string these individual programs together so that it knows that you go forward a certain number of degrees, and then this one also goes forward a certain number of degrees. Any of these can stand alone, as vectors do, but when you add them up, basically, u plus v, if you think about what u plus v is looking like, it's saying basically you go an angle and a magnitude of u, and then let's just say v's some little shorty thing like that. U plus v is looks like that. Now w, the sum of two vectors, is where you would end up, okay, where you would end up if you did both u plus v, okay, from the starting point. So w is going to start where u started and end where v ends. Now here's the thing though, u and v are each their own program. So if I were to graph my particular u and v right now, u would look like that, like my u. V all by itself looks like this. And w would look like this. What you have to imagine, if you're adding u plus v, is you're translating that. I don't know if it'll let me grab this, but let's try. You're translating the v up to here so that it's close enough so you can see, okay, but really just like that is still u plus v equals w, okay, because you haven't strung them together in all one continuous program yet. So what you're looking for is three vectors, which when you do u and then from the ending point of u you do v, that w from start to finish is sort of the sum of both of those movements. So what I'm going to do is this. If you look at u, v, w right here, v goes, I'm going to use the slopes, up 1 over 2. So from the ending point of u, if I go up 1 over 2, that's where v would be. And you can see that in translating u plus v, w does not end where v ends. So A is not your answer. Looking at the second one, if you've got u right here, and let me do it in a color here, there's u. Okay, v, if I translate v, and this v is still up 1 over 2, up 1 over 2, v would be right here. Is there any way that w is the sum of those two moves? No, it's not. W is going totally the wrong direction. If you started w where you started u, it would be like right there. So that is not the sum of u and v. So looking here, I've got u and V, again, V is up 1 over 2. This is V translated up. So that's me adding the two vectors. And W, there's no way that W is the sum of those. W, if you started where you started, would be going in completely the wrong direction. So C is not correct. So now look at D. Let's hope this is it. U plus V, again, V is still up 1 over 2, up 1 over 2. Notice that V translated would be right there. So U plus V, and then W travels the sum of the entire distance and direction that U and V travel when strung together. So that answer is D.